All right, someone asked for 13 from 4.3 last night. I wasn't able to do it then, but I am now. So in problems like this, we're trying to find the critical points and the interval of increase and decrease and stuff like that. To do this, we pretty much always follow the same procedure. The very first thing we're going to do is we're going to take a derivative of our function. Sine x here is going to become cosine x. And cosine x is going to become negative sine x. And then we're going to go ahead and set cosine x minus sine x equal to 0. Now, unlike a lot of the polynomial ones where you can just factor and solve for some value, here you have a bunch of functions, or a couple of functions. So what we're going to do is we're going to move the sign over to the other side and set these equal to each other. Now, we're looking on this graph over here to the right. I went ahead and used Desmos to graph sine and cosine. And I'm looking for everywhere that they are equal. Like right here, they're equal. Now, interestingly enough, I could just divide both sides by cosine, right? And if I do that, I'm going to get 1 equals tangent x, okay? So that tells me everywhere tangent equals 1, I'm going to have one of my critical points, right? I'm going to have this equaling 0 business going on. And that means right here, right? It's in the same spot. It's at pi over 4. Okay? Now, that means here x equals pi over 4. But we have this whole interval, the whole 2 pi interval. And tangent happens more than once, where it in that interval to 2 pi. It also happens over here. You see how we have right there, we get to 2 pi. We also have another value of 1 here at 5 pi over 4. It's where sine and cosine are equal to each other but negative. And then they divide and they become positive. That's what generates the 1 on tangent, right? So we also have to say we have a point at 5 pi over 4 where they're equal to each other. And that's what generates the 0. So we get zeros, we get critical points at pi over 4 and 5 pi over 4. Okay, right here. We also, though, want to know what's happening in between from 0, right, up to pi over 4 and 5 pi over 4. So to find that out, what we have to do is we have to pick points that are inside this interval. We could pick like pi over 8, and we could pick pi, and we could pick 3 pi over 2. All three of these are good points. They're all inside of these intervals. They live right here in the interval, right? And they'll tell us what's happening if we plug them back into our prime function. So if we take cosine of pi over 8 minus the sine of pi over 8, we'll get some answer, okay? And that'll tell us if this interval right here is increasing or decreasing. Now, when we do this, we get doesn't matter what the value is, but we get a positive number. Okay, so that we're increasing on this interval. Here, when we plug in pi, the pi right there, we get cosine pi, which is negative 1, minus sine of pi, which is 0. So we get a negative interval. This equals a negative number. Doesn't matter that it's negative 1. It only matters that it's negative. Okay? So we're decreasing on this interval. Decreasing. Increasing. And for this last little bit of an interval, 3 pi over 2, the cosine of 3 pi over 2 is 0. And we're going to subtract the sine of 3 pi over 2. Okay, we're going to subtract that, and it's negative 1. Okay? And that makes it a positive. Doesn't matter what the value is. And that means this interval here is increasing. Now, if there's more questions about this, let me know. Happy to try to clarify some of this stuff up. But that's the gist of what's going on. I didn't bother to try and graph cosine minus sine x, but you could do that and you could see why there are these flat, shallow points, or, you know, when I say flat, I mean no slope. You get this point like you have here on cosine, there's no slope there, there's no slope there. I would hazard a guess this is going to zero out right there where they subtract, and you're going to get some sort of a min or a max, depending on what situation you're in. And again, like I said, I hope this helps. Please ask questions if you don't get it. Have a great day.